In this tutorial, I'm going to show you how to use the anything to 3x3 cookie cutter file to cut up any file you like and turn it into a 3x3 Rubik's Cube style puzzle. Let's get started. How's it going, guys? Angus here from Maker's Muse. So last week I showed you these. These are my anything to 3x3 puzzles. This is a hexasphericon. It's my favorite one I've made. Turns really nicely. This is a object of constant width, 3x3. It's going to be a lot of fun to try to solve that. And then you would have seen this one, which is my pineapple 3x3. It's an actual 3D scan of a pineapple, and I created it into a puzzle. It's, it's a little bit nightmarish. So all of these files were created using a 3D cookie cutter, which I've called anything to 3x3. And this is an in-depth tutorial on how to use that file. So you can find the link here to purchase the file and all the assets needed to make your own 3D printed 3x3 puzzles using it. And you can use it to create literally any shape 3x3 you like. So let's get started with what you'll need. Okay, so to use the anything to 3x3 file to make your own 3D printed puzzles, you will obviously need a 3D printer of some kind. The parts are quite small, but there is an awful lot of them, and you do need fairly good tolerances, so you need a fairly well-tuned machine, but an FDM 3D printer is perfectly fine. All these puzzles were printed in PLA filament. You'll also need some screws, so I used M3s, and they are M3 by 25 millimeters. And you'll also need some M3 lock nuts. These are nuts with a little bit of plastic in them, which stops the screws backing out. And it's using these lock nuts that lets us form the actual core of the 3x3 puzzle to stop the screws actually backing out during use. And then finally, you'll need springs. Now for me, I needed springs quickly, so I actually used the ones out of pens. I bought cheap pens with the sort of spring-loaded clicky movement, and these springs in these pens have the right inner diameter that you need for my puzzles. So they're actually too long, so I cut them in half. But basically for springs, you want to find ones with a 3mm minimum internal diameter and outside diameter of a maximum of 7mm, and you want a length of about 15mm before being compressed. So it's variable. Springs are springs. You don't strictly need them for the puzzles to work, but they make them work a heck of a lot easier. And finally, when it comes to assembling the puzzles, you will probably need a little bit of sandpaper to clean up some rough edges and some silicone lubricant spray, which you spray into the puzzle to help free up and lubricate the parts so they turn really easily. Okay, so fire up the anything to 3x3 archive and you'll find the following file types. There is STL files in there, and also some step files, STP, and also some Fusion archive files, which are F3D. These are all of the anything to 3x3 cookie cutter file. And if you have an organic mesh like the pineapple that is a STL or similar mesh format already, you will be using the STL file format of the cookie cutter. And if it's a parametrically drawn object, like in the case of the hexasphericon, which I drew in Fusion 360, we'll be using the archive file or the step file. If you're using a different CAD program that takes step, you might want to use that. But I'll be using the Fusion archive file to show you how to cut up these shapes that I have already drawn in Fusion. But I'll be showing you the full tutorial of how to use both using Fusion 360 and how to use the mesh file in Bforartists, and you can also use Blender if you like. To complete this project, you're looking at roughly 100 to 200 grams of filament needed depending on the infill and size of the overall puzzle you choose. And for print time, you're looking at 15 to 20 hours of total print time. It does take a long time to print this puzzle, but the results, in my opinion, are well worth it. In terms of assembly, it'll take probably about half an hour to post-process the parts and put them together into your final puzzle. But before we do anything, first you just need to grab the core. This is simple. All you need to do is 3D print it. Now, as I said, it's designed to fit M3 lock nuts, so you want to make sure you print it in the orientation provided to make sure that it prints correctly without needing any support material. So you do need to turn support material off when printing the core to ensure all the gaps are free. What I found when printing this is you want to print it nice and slowly because it only has a small contact area at the base, and you want to make sure you print it with a fairly high infill and at a fairly decent temperature so the parts have really good layer bonding. I actually printed this in ABS, but you don't strictly need that. Just make sure you print it with a nice thick outer layer and a nice sort of slow speed, and ensure that the part has a very high strength. Otherwise you will get delamination as you tighten things up. It's unlikely, but you want this part to be as strong as possible. So just kick that file off, printing nice and slow on your 3D printer of choice while we start working on the anything to 3x3 puzzle. So let's start with how to get the anything to 3x3 into Fusion 360 or any similar CAD program that takes a step file. So in the folders, you'll find a .f3d and a .step. Fusion will take both of these in, but the .f3d is a Fusion archive file. It's specific to Fusion 360. So if you're using something like SolidWorks or Inventor or Rhino or a lot of those other programs, you can use the .step. But in this tutorial, I will be showing Fusion 360 because it is free to startups and for education. So it's important to know the final size of the model you'll be making. The cube design itself, if it was going to be turned into just a standard 3x3, is actually 80 millimeters across. I'll show you here. So it's a little bit larger than a standard Rubik's Cube or standard puzzle cube, Twisty Puzzle. That's because for 3D printing, the mechanism needs to be a little bit chunkier. We don't get the same tolerances as you do for injection molding. So whatever file you're creating, whatever model you're creating, you need to keep that rough dimension in mind. It doesn't need to be 80, it can be a little bit smaller, it can be bigger. The actual file does allow for it. But if you want to have cells the same rough size, you're looking at around 80 by 80 millimeters. So the thing about importing a F3D or step into Fusion is I want a feature tree. So the feature tree, as you've seen in my previous videos, is where you can go back in time and edit sketches and features easily. There's a whole timeline down the bottom of the modeling workspace. However, if we just bring in the anything to 3x3 model and start working on it, which is tempting, you do not get a feature tree. That's because Fusion defaults to direct editing, but we want to be able to preserve and go back in time and change things. So there's two ways you can do it. But before we do anything, we need to get the file into Fusion. So to do that, just start with a blank workspace and go to File, and then New Design from File. And you notice that Fusion has all these different supported files, so in future reference, .igs or IGES, .sat, .smt, .stp or step, and .f3d are the supported import formats. So I'm just going to use the .f3d here, but again, you could also use the .step if you want to. Both those files are in the folder, and there's two different types of each. There's no numbers and the standard. So the standard does have markers, numbers used as symbols to help you assemble a puzzle if there's different shaped pieces. And if you really don't want them, or if they start to show in the edges of the puzzle, if you're cutting it really fine, you might want to use the no number version. But just keep in mind, assembling a puzzle which is just shape only with no numbers proved to be very challenging. So I'm going to go with the numbered version, standard, and then I'm going to open that up. And here we go, it creates a new workspace with our anything to 3x3 puzzle. But this is what I mean, if you start working on this here, there's not going to be any timeline. So we just want to save this. So save it as anything. So I'm just going to save this into the Cloud Fusion folders, but if you're again using SolidWorks or something, you save it obviously into a native SolidWorks format. And then save. Okay, now we need to open another workspace, and there's two different ways we can go about it. So let's crack open another workspace. You can either bring the file in first and then work around it, or you can design your model and then bring in the anything to 3x3. Both methods will work, and it depends how you've modeled it. So I'm going to demonstrate bringing it in first and then modeling, but if you've already got a file modeled, then you can bring it in afterwards. It doesn't really affect anything, but most importantly, you need to have a blank workspace saved before you can bring it in. It won't let you do it otherwise. So I'm just going to save this as, what am I going to make? Let's make a sphere. Sphere 3x3. This is going to be the world's simplest 3x3 twisty puzzle. Okay. So I'm going to make a sphere, and I'm going to bring in the cookie cutter anything to 3x3 first to inform my design. Again, you can do it afterwards. That's totally fine. But to do it, you simply open up the original file and drop it in. So in Fusion, it's very easy. Your recent data will be here on the left-hand side, and you simply click it, right-click, and insert into current design. Okay, we've brought it into our workspace, and we have the move and copy window, but you don't want to move it anywhere. I've designed it to be in the origin, so the center is 0, 0, 0, X, Y, Z coordinates. So don't move it, just click OK. Rightio. So I've now got a new component, which is our anything 3x3 cutter, and you can start modeling as you like. Down the bottom you can see it's actually got a timeline, which is what we want. So I'm just going to hide that for now, and I'm going to start creating a sketch. You notice I'm not actually created inside the anything 3x3 component. I'm not sure that actually matters in my tests. If you're making something very simple that doesn't really need to interact with mates or anything, joints in Fusion, it doesn't matter. However you feel more comfortable. This is just how I do it. But we're going to grab a circle here, pop it in, and I did say that 80 millimeters was a good size, so let's go 80. This is obviously not a Fusion 360 modeling tutorial. There's way too much to cover. I'm just going to create a revolve of this to create a sphere. Alrighty. So this is our sphere, and if I just unhide our anything 3x3 cutter, you can see the sphere interacts nicely. Just hide that. It interacts nicely with our cutter. So any shape you like, 80 would be the minimum I would recommend. You can see the corners start to get pretty small when you do a sphere at 80 millimeters diameter. But there's also a maximum size the cutter can handle, and that is 140 millimeters across. The edges are extended out to 140 millimeters. Any more than that and the cutter won't completely cut through the shape. So 80 minimum and 140 maximum as a cube. That's probably what I would recommend. Alright, so to actually do our cut, it's a Boolean difference. Very simple, and I've used this many times in the past and shown it on the channel. You go to combine here, and then our target body is the sphere or the object you want to turn into a 3x3 puzzle, and tool body is here. That's our anything to 3x3. The operation is cut, and that will take the 3x3 and cut it away from your shape, no matter what shape that is. One thing I have noticed is because the anything with 3x3 is its own component, it says keep tools, you can't get rid of it, so that's fine. It just means it'll stay in the workspace and you just hide it when you're ready to export. So okay, cut. And this is going to take our anything 3x3 cutter, and if I hide it, turn our shape into a ready to go 3x3 Twisty Puzzle, which is super cool. And actually that looks really quite elegant. I haven't done a spherical 3x3 before. The way these parts are designed is you can print them no matter what the surface detail is. So even though this is all curvy, they all print on their side or on their back. So don't worry, the surface detail can be whatever you like. You can have text on it, you can do whatever you want here. And if you go to bodies, there should be 26 bodies here, if you've done it correctly. If there's more than 26 bodies, it might mean some things were like overhanging, like for example, the pineapple twisty puzzle. Some of the parts overhung the cutting area, so they're in midair and there were little tiny areas that I just deleted afterwards. So you want 26 parts and you want to export it. And you can export it one by one, but I find the easiest is to actually just make sure the anything 3x3 cutter is hidden, and just right click here, sphere 3x3 or whatever you called it, save as STL. And we're going to save out all of those parts as one STL, and then after the next tutorial on the mesh editing in Bforartists, I'll show you how to actually separate it out and arrange it for 3D printing. Alright, so let me show you now how to get a mesh like the pineapple and then convert it to the 3x3 puzzle using our cookie cutter. So this is Bforartists, and you could use Blender as well. I just prefer Bforartists because the selection sort of defaults and that sort of thing are more familiar to me coming from Fusion 360 and other similar CAD programs. But again, there's lots of great Blender tutorials out there, and what we're going to do using the Boolean difference modifier is exactly the same. So essentially what we're going to do is get the two meshes, and we're going to Boolean difference away our 3D cookie cutter to make the mechanism. Okay, so to begin, let's grab our anything to 3x3 mesh. So we're going to go to File and Import and STL and anything 3x3. So again, we've got the two types. We've got the one with no numbers and the one with the numbers to use as a way to align the parts when you're assembling the puzzle. So I'm going to go with, again, the one with the numbers and import STL. So here is our anything to 3x3 mechanism. And now we're going to bring in what we want to cut away from. Now, unlike Fusion 360, it's a little bit more manual in terms of lining. So let me show you. I'm going to go to Import, STL, and I'm just going to grab my pineapple 3D scan. So 3D scan, and I have a pineapple scan right here. Import STL. So right off the bat, the pineapple is actually above, above the 3x3 here. And I'm going to have to align it into our mechanism before I can actually do the Boolean difference. So I'm just going to grab it here and just pull it down. So the way I like to do it is I'm right-clicking to orbit and I am holding down the mouse wheel to pan. Again, this is Bforartists defaults. And I'm just going to try to get this pineapple in the center of the mesh by just rotating around different angles. I can move the mesh or the pineapple, it doesn't matter. And I'm just trying to get it, you know, as close as possible. This will be very much manual depending on what mesh you're using. But you want to make sure, for example, these are where the screws go. So I can actually just rotate it. So I'm just going to rotate it on the Z direction. Let's try just 30. Okay, that looks good. So that just moves it off onto a corner piece, sorry, an edge piece, which is good. And honestly, that looks quite good. You can also scale as well. This might be a little bit big in terms of keeping the segments even, but for this, it's probably fine. And now the important part is the Boolean difference. So that's called a modifier. And again, it's the same in Blender, but over here on the right-hand side, this little tool, this little wrench. So we're going to click that, and we want to add in a modifier. So I'm going to select Mesh, making sure I'm selecting the pineapple. See, it highlights the edges there. Add modifier. And then we want to generate a Boolean. And there's different types: intersect, difference, and union. Union would join it together. But we actually want difference, which cuts away the other mesh. The other mesh we want is the anything to 3x3. And this, we apply that. And that's done. If we just get rid of the anything to 3x3, just delete it or move it out of the way, you can see here that it's actually done what we needed. We now have this mesh. It's still all in one shape, but it's actually lots of different pieces now. So simply to export this, I'm just going to select it and then File, Export. And again, we want STL, and then you save it into a folder. Now we're going to fire up ideaMaker, and I'll show you how to separate these parts out from either Fusion or Bforartists, and then arrange them correctly for 3D printing. Takes a little bit of time, but it's well worth the effort. Another thing you might want to do, just in case you're worried your file may have printing errors, is to fire up Meshmixer and bring in your mesh from either Fusion 360 or Bforartists or Blender, and we can actually take a look at it in Meshmixer to see if there's any errors. So to do that, you go to Analysis and Inspector, and it will find any points that it doesn't quite like. Now this is very fine, no issues at all. The mesh I originally used probably already had these errors anyway. For example, like here, that's not that nice looking. These are all just artifacts of the original mesh. So I can just repair that, or to be honest, you might not even need to, and you can re-export it. But if you have tons of errors, then that means something's gone wrong somewhere. Your original mesh might have been poor, or Fusion might have had a bit of a corruption or a bit of an error or issue when exporting the STL. You don't want to see any, or at least very few errors in terms of your STL. You don't want to see much. If you see lots, something's gone wrong, go back to the drawing board. Okay, this is the fun bit, arranging all the parts for 3D printing. This is tedious, I'm not going to lie, but it's not too difficult. This is where we get our file that we've just cut up, and we break it into the various edges and corners and centers to print them correctly on our 3D printers. And you want to take the time to do this properly so you can guarantee the prints work. Otherwise you might have failures, and it's really not fun to have that. Okay, so we've got our model, and it's been actually cut into what should be 26 pieces. Now there might be a few additional small chunks of mesh that have been cut off with our Boolean difference, because this is a 3D scan, for example, and it's got all these little nasty bits on it. So they're going to be deleted and removed. We need 26 individual components if you've done it properly and if it's worked correctly. And to separate them, you can do it right here in ideaMaker. So what we're going to do is select the file and select Model and Auto Ungroup. What this does is splits apart all the individual components out of that STL, so we can now manipulate them and align them to the bed. So to do that in ideaMaker, it's a little bit iffy, but basically I do arrange all models, and then now I've done that, I'm going to close this window, and then I'm going to go to model, and we want to go to put all models on platform. There we go. So it's going to put them all down on the bed. The ones that are red are outside of the print volume, but we're just arranging them here. We're not printing them all at once. That's a terrible idea, because if one part fails, then it's going to cause a knock-on effect. Plus, some parts we want support material, and some parts we don't want support material. So the first thing you'll notice, guys, is that these are just orientated terribly. You don't want to print them at all like this. So you want to print them in different orientations. For the centerpieces, you want to print them on their side. So you want to print the centerpieces like this. For the corner pieces, you want to print them standing on their little base like this. And for the edge pieces, you want to print them on their side like this. In terms of support material, you will need it for the edge and middle pieces, the center pieces, but you don't strictly need support for the corner pieces. However, depending on your mesh, you might have some weird geometry on the top of it that might need support. But basically, they've been designed to print without support. We do need to put them in the right orientation, and to do that, you actually need to do it one by one by going to Model and Lay Flat, or Shift L. And I'm just going to go around to every model and arrange them in the correct orientation. So starting with this corner one here, you can see it's weird, but we want to align it on this piece there. Apply. That's the correct orientation. For this piece, that's an edge, so we want to put it on its side like this. Apply. This is another corner piece, so when I put it on its base like that, apply. Similar here, this piece on its base, apply. This one is an edge, so put it here. Even if they look flat, you might want to just double check that they are. Sometimes they come out at slightly weird angles, so apply. Apply. And yeah, like I said, this is the tedious part. This is a centerpiece, so you're just gonna put it on the side there. Apply. This one here. Apply. And you go around to every single one, and then make sure they're all properly orientated so that they will print correctly. If you do not do this properly, guys, the puzzle will probably not work. So this is tedious, this takes some time, but it's well worth it to make sure the puzzle is going to work. So it's going to be like a 20-hour print. So you want to make sure that the 20-hour print actually succeeds instead of having a part that fails and knocks over and wastes like 50 grams, 100 grams of filament. Okay, so now we have the parts all correctly orientated for the printing. We need to make them into their own individual groups because you do not want to print them all at once like this. I tried and they can fail. So what we want to do is separate them into the centerpieces, the edge pieces, and the corner pieces. The corner ones especially, because they have a high tendency to fail and you want to print them slowly and on their own. So let's start with the centerpieces, and I'm just going to grab them. They look like this, and I'm going to close the Lay Flat tool and move to the Move tool. And I'm just going to move them, making sure I'm not moving them in the Z direction, just the X and Y. I'm going to move them all nice and close to each other. Not too close that they're going to touch and interfere with each other, because they will need support material, don't forget, but I'm planning to print these together. So there's one over here as well. Move him here. And there should be 6 centerpieces total, so make sure you're not missing any. Here's one as well. Again, don't worry about the colors, that's just ideaMaker telling you it's out of the printable area, but we're not going to actually print, well, I'm not planning to print these in ideaMaker. I actually would be slicing them for the Prusa, so I'm going to save these 6 centerpieces as their own individual STL. And to do that, I'm going to select them all, holding down Shift, select, and then you go to Model, and Merge. Now this has merged them all into one group now, and I can actually now export this as its own STL mesh. So File, and Export Model, and I can export this as Center Group, for example. And this is giving me my centerpieces all on their own, ready for 3D printing. This is really handy if you like need to reprint the puzzle in future, or you want to do different colors or massive batches, or you want to change slicing settings, etc. You only need to bring this in and change that instead of having to rearrange them again. Again, this is tedious, but you want to do it properly first time. So now that's done, I can just move them out of the way. And next will be the corner pieces. So again, it's going to move them into their own area. So you can manually align these as close as you like, but again, you don't want to go too ridiculous. But that looks pretty good to me. And in terms of our corner pieces, there should be 8. And they are all still correctly orientated. Looks good to me. So I'm going to again hold down Shift, get those bad boys, and then do a model merge. That looks good, and I'm going to export this. So File, Export Model as Corner Group. And finally, we need to group and export our edge pieces. So we have these pieces here, and again, you don't want them too close to each other because there will be support material, but I'm just going to bring them out over here and bring them towards each other. I like sort of alternate them like this. That tends to look quite good. It seems to work all right. Again, not having them too close to each other. You can rotate around if you so choose. You could spend more time getting these closer, but that's perfectly fine in my opinion. And just visually make sure they're all on the same plane. That looks fine. And I'm going to hold down Shift, select all of them, and once again merge them under Model, Model, Merge, and then finally export this, Export Model as Edges Nest. Okay, done. And as I said at the start of this, you might have some leftover bits. See all these little little tiny bits of crap? These are just loose bits that got cut off that were maybe overhanging where the anything the 3x3 cut through. They're useless and you don't need them, so don't worry about that. That's why I like to do it this method. You export it, and then that you have these fresh, clean, exported, nested files that you can then bring into your preferred slicer to slice. If your preferred slicer is ideaMaker, that's fantastic. Just bring them back in, or you can just slice them right here. But I printed these models mostly on the Prusa Mark III, and to be honest, I use the Prusa slicer for the Prusa Mark III, so I'm going to show you how to do the slicing of these files and the parameters you need in that software. But nothing against ideaMaker. If you're slicing for a raised printer or you use ideaMaker, the process is completely identical. Okay, my friends, now we have the slicing portion of the tutorial. This is where I'm going to show you the correct slicing parameters you need to produce your anything to 3x3 puzzle. Some parts do need support, some don't, some have special considerations, and as I showed you on terms of exporting them into their own separate nested parts, that saves so much time. So to start with, I'm going to show you how to do the corners. So I'm going to grab my corner group from before and bring it in. Here we go. So these parts print without support material. You could turn support material on if you're concerned, but they're designed to print without support. So as you can see here, the overhang is not very severe. It's at the limit where it's fine, but the top surfaces of your print, depending on what the model is, keep in mind, this is my Pineapple 3D scan, you might need support material. Like, you know, these little overhangs here, that's from the mesh I used, and that might need supports. However, if you're printing something like this hexasphericon or a standard cube or whatever, you're very unlikely to need support material. So I'm not going to turn support material on for this print because most often you don't, but you may want to turn it on for your model. But what I am going to do is use a very large brim because see this contact area down the bottom here? That's very small, and if the part gets knocked, you want to make sure it doesn't come free and fail because it'll kill all the other prints in the process. So for printing these parts, I recommend 0.15mm layer heights. So I'm going to go to my presets. That's the optimum for the Mark III. I haven't really changed that. But under print settings, we are going to add a very massive brim to make sure it gets well stuck down. You break the brim off afterwards just by hand. But in terms of adding a brim here, brim width, I'm going to make it 6mm. It's a nice, decent brim. And as I mentioned, I'm not going to turn support material on here, so I'm going to untick this for the corner pieces. But if you do need it, there's no shame in it. You just turn it on here. And under infill, it's currently set at 10%. You might want to increase that. These parts are very small. 20 is probably fine. But one thing I do recommend under layers is having 4 perimeters. So 4 perimeters gives it that little bit of extra strength where it starts going into itself and out. You don't want the part to snap away. That would be really frustrating. So 4 perimeters gives it just a little bit of extra strength, 0.15 millimeter layer heights. I will use support material for the other pieces, but for the corners, you generally don't need it. We'll do a visual inspection to make sure, but yeah, you generally don't need it. So let's go to preview and have a look. So here are our corner pieces, and we can scroll back down through the layers to see how they print. So as you can see, that brim is really quite large, but it is critical because these parts sort of are quite large as they taper up. This is why we need 4 perimeters. You want to make sure this area is really strong, because I had a few early prototypes snap at this point, which was very frustrating. And as it comes up here, this is where you may need support material depending on your model. So as it starts coming to the top surface and the top texture, you can see it starts to do some strange things, depending on what your texture is. For this, it looks okay. I mean, that's whatever. I'll probably actually just cut that off because it looks sharp. And I can't really see any areas that would necessarily fail catastrophically. So this looks good. Let's do our edges next. Okay, and now we're going to do the edges next. So there is 12 edges in the puzzle. This is the print that will take the longest to finish. So in terms of print settings for your edge pieces, we don't need that huge brim, but we do need support material because it has this overhanging tab here that you just have to support. You can't have it without it. So we're going to go to print settings and we'll get rid of the brim. You don't need a brim for these parts. You can if you want, but you don't need it. We're going to go to support material and turn it on. My overhang threshold is at 45 degrees. That seems to work really well. And just make sure you go down here that support on build plate only is not ticked. The reason we don't want this ticked is you might need support on the face of the piece, and if it has to build support as it goes up on the piece, then you want it to do that. Otherwise, if you have that ticked, it won't. So that looks good. I'm going to go to slice. And here are the pieces with support material generated. As you can see, though, that surface, because it's really rough from the pineapple scan, does need support material, but also those tabs, they need that nice amount of support material to hold it in place. And in my experience on the Prusa, that support just breaks away. It's very easy to clean up. You might need a little bit of sandpaper, but it cleans up pretty easy. And these pieces will take the longest, so just take care. Make sure you have enough filament. Make sure the bed's clean and not oily or dirty, because you want this part to succeed, because it will take quite a while to complete. So let's finish up on the centerpieces, which are a mixed case. Alright, so these are the centerpieces for our puzzle, and these pieces also need support material. However, they have a bore through them, as you can see here, this hole. And in my experience, you actually generally want to, if you can, tick that box for generating build support from the print bed only, because you don't want to bother pulling support out of that hole. If you have to, if the face of the puzzle needs support, if you've got like overhangs and things, then fine, you can't avoid it. But let me just demonstrate under print settings. I'm actually going to tick support on build plate only and go back and slice the model. And as you can see here, it's building support material up, but only from the build plate. It's not filling that hole that forms there, which means post-processing is a lot easier for you. Again, if you see the need to actually have support material be built on the part, like if you have a face here that extends out and it's unable to build from the bed, then you will have to untick that box, and you will have to punch through those holes using a very fine pick or something, or a drill bit or something. I find if you can tick that box and avoid putting support material in the bores, you get a much cleaner, nicer bore. It's easier to get the prints done and off the bed, and less post-processing for you. And that's all the pieces you need to complete. It is confusing and complicated. This is a very advanced model to complete, But hopefully guys, send those to the printer and I'll see you when you get the parts to show you how to assemble your brand new 3x3 puzzle. Alright, now time to assemble the puzzle. If you've gotten this far, congratulations! This is a lot of 3D printing. So before we proceed, make sure you have all the parts. You need 8 corner pieces, 6 center pieces, 12 edge pieces, 1 core, 6 M3 screws, 6 M3 nylock nuts, and the 6 springs. Just make sure the parts are cleaned up and there's no brim left on them and they're all ready to go, maybe using some sandpaper. Now to assemble the core. Now the core needs the 6 nylock nuts pressed into those slots. Make sure they're clear, there's no filament wisps in them. And it can be tedious, I'm not going to lie. Getting them lined up and pushed in can be a little bit challenging. So take your time here, maybe using a pair of pliers to line them up. They go in flat sides, so they tend to sort of want to rotate on the slot, but make sure they just go in nice and flat. And once they're in place, I use a small screwdriver to center them in the hole. You might find some of the slots are quite loose and the nuts don't stay in place. In this case, I like to just sort of hold them in place temporarily with one of my M3 screws. So when I'm assembling the puzzle, I just take that screw out once I'm ready to actually attach the centerpiece in place. And as I said, some of the parts you might want to just use the edge of a table or something to press them in if you're finding they're just a bit too tight to push in by hand. And there you go, that's your completed core with all of the nylock nuts pressed into place. Now time to assemble the puzzle. You want to gather your M3 screws and your springs, and I like to put the springs onto the screws just ready to go, because as you're assembling you don't want to sort of fiddle and lose your spot. So the best way I've found to assemble a puzzle is to start with 4 of the center pieces. So they do have the numbers imprinted on them, whether they're mirrored or not, acting as symbols. But what I found is to actually use a diagram to help you find the first 4 centers to get started on your puzzle. So I've chosen these 4 here, and the B stands for a mirrored number, so it's a backwards 7 for example. You want to find these 4 center pieces going around the outside of the shape, and they will be the same on every puzzle because they're on the cookie cutter file. And you want to find these, and they will be positioned in these positions around the core. So start with these, and then you can start matching up the side and edge pieces, the corner pieces in place to assemble your puzzle. So I'm going to locate those pieces on my puzzle, and the way I put them in place is to get my screw with a spring, put it in through the center piece, line it up into my core, making sure that nut is centered as I showed before. And you don't want to tighten up too much, just enough to engage with that nut and you get a bit of play, as you can see here. You want play until your puzzle's finished, and then you can tighten all those into place to get a really good fit. So here I've got all those 4 center pieces assembled, and I can start moving on to the side or edge pieces. And these will correspond with the correct number. So for example, 2 will go to a mirrored 2. They need to line up like that. But also you can use your texture. So here I'm using a hybrid of both, finding one which lines up with the right symbol, and then finding out which texture lines up, and then getting it into place. And you want to do this all around those 4 pieces. So what you'll end up with is an entire center slice of your puzzle. Once you're happy with this, we can move on to one side, and this is where you'll start putting your corner pieces in. It's worth noting that this stage of the assembly is tedious, so fire up a stream or something. I was watching Tim Schmoyer at the time, and get it together. And what you do is you put that final centerpiece in at the end, and that locks all of the parts together. So you put the corners in, the edges in, then the center, and you flip the puzzle over and do the same on the other side. Take your time, get this right, because it's a real pain if you have to take the puzzle apart because you got a part in the wrong place. You have the symbols and the outside texture to help you get it in place. Right about now is also a fantastic time to spray some silicone lubricant into the puzzle to help things turn freely, and then put that final centerpiece in place, and you're done. Give it a few turns to sort of wear the parts into each other. The more you do this, the freer the puzzle will turn, and tighten up those screws gradually till you get the tension you're after. And that's done. Congratulations, guys. You now have your own custom 3x3. So there you have it, guys. A full tutorial on how to make your own anything to 3x3 puzzle, please do share your results with me, guys, down below in the comments section of this video. I'd love to see how you do, and if you have any trouble at all, let me know as well, and I'll chip in and help you troubleshoot your issues. If you have a mesh with errors, then you might have trouble using the Boolean difference. But overall, I've found it to be quite a sturdy method, and once you figure out, get your head around assembling the puzzles and that sort of thing, and sort of getting the parts nice and clean, they work really well. Just use them and turn them over time, and the parts wear into each other, and the puzzles will start to turn really, really nicely. So if you did enjoy this video here in Maker's Muse, guys, I'd love to have you subscribe. Thank you so much for supporting the channel by purchasing this file if you did. And I will look forward to seeing you again very shortly with all sorts of more crazy mechanisms here on Maker's Muse. Catch you later, guys. Bye.